Welcome to the lecture on actual geoprocessing. Geoprocessing is the key tool in our GIS toolbox. So much is possible with geographic information system, from environmental conservation to environmental management, smart cities or climate change adaptation. You can run any kind of analysis. You can create complex models of the environment. The limit is really just the sky. So here we have the actual true power of GIS tools, the vast availability of geospatial analysis. But first of all, let's have a brief recapturing of the basic GIS functions. These are at the center for capturing data, and we use editing and digitizing tools for that, storing and managing data with our data management tools, the data analysis, and that's what I will talk about now, and finally data presentation. You could look at navigation and viewing tools as a fifth one. Starting very simply here with a screenshot from one of our tables, you can have a calculation of area size, or the length of a feature, for example, a boundary, and then sort these or run geometry calculations or statistics. In this context, I would like to quote the famous geographer, cartographer Michael Goodchild. He gave an example during one of his lectures. Do not trust GIS too much, but keep thinking for yourself. If we calculate the coastline of Italy, for example, in GIS, GIS will most likely give us a result precise to a fraction of a millimeter. Does that make sense? No. Even during the course of one day, the coastline of Italy changes a few hundred kilometers just because of tides. So always think about how far can I round these numbers? Does it make sense what I get as a result? That's the most important lesson here. Still stay critical and review your results. Reflect on your results critically. But as long as you do that, then the possibilities of GIS are endless. You can start with statistical analysis, for example, calculating the area sizes of different land users or land users affected by a development and land users affected by pollution, etc., etc. You can combine these and other analysis, maybe a heat map, maybe walkability map, with elevation analysis, here slope and aspect, and create a suitability model. Suitability of land for future settlement, suitability for wind energy or solar energy. In this way, you can create suitability maps informing political decision making and finding the best location for any kind of project, agriculture, energy, or settlements. These are some of the most basic analytical functions here. This is what we will start with. You might use clip, for example, to clip your project area from your geodata set. Or you might use union if you get a couple of map sheets. That's often the way that Ordnance Survey and other organizations hand out their geodata. You want to combine two map sheets to one. It's kind of a rule of thumb that your project area is always on the boundary of at least two different map sheets, so you need this quite often. Then third, buffer is very useful. Just a couple of examples. In transport planning, you might put a buffer of 300 meters around every bus stop because that's roughly the distance that people are willing to walk in Europe. And if you put buffers of 300 meters around every bus stops, you will get a map that is showing you which areas are served by existing bus stops and where do we have a gap. So where do we put future bus stops? Another example, in Germany, in most Länder in Germany, most states, you have a rule that farmers are not allowed to use pesticides within 10 meters of a water body. So you calculate a 10-meter buffer around all the water bodies to find out which areas are protected from the use of pesticides. And there are many more applications for buffer. And if you run these and other analyses, you often get very complicated maps with a lot of small patches, but these small patches can be simplified and unified again. And that's where dissolve is a very helpful function to summarize these results and simplify it again. These are only 4 very basic examples of GIS functions. There are many more, and I invite you to our practical exercises to explore these in detail. Here, an example of analysis with raster data. The previous analysis always ran on vector data. With raster data, each pixel is analyzed, part of the calculation. This could be in analysis of solar radiation or in a hydrological model. What you have to remember here is that analytical functions are different depending on whether you analyze vector data or raster data. And some functions, like here the solar radiation, might not be possible with a vector data map. In this case, you might have to convert your data first. Another example is the raster calculator, which is very helpful, for example, to calculate a suitability map. With these small short examples, I finish this introduction to geoprocessing and GIS functions. And again, I invite you to actually apply some of these analyses in the exercises. Thank you very much.